We're going to look at logarithms. Now, logarithms have a scary name, but they're not really that bad. When we're talking about logarithms, all we're really talking about is the index, power, exponent in a statement. So if we look at our two forms here, we know this is our index form, that is a base to the power of something equals y. We can actually write it in a different way using logarithms. So we can say instead in log form, the log of a y equals x. So it's a pretty straightforward process to actually change between the two. Let's look at an example. So if I have a look up here, let's pretend I had 3 squared and it equals 9. If I wanted to then change that over to logarithm form, it's pretty straightforward. I just write log to represent logarithm. We put our base goes down the bottom here. Then the next thing we do is whatever it equals on the right hand side. So in this case, it's going to be 9. And then we have our power on the other side of the equal side. And the way that we would read that would be the logarithm of 9 to the base 3 is 2. Essentially, what I'm asking here is, I'm just going to rub this off. Essentially, what I'm asking is using the base 3, if I have the result 9, what will the power end up being? Pretty straightforward process. I'll do a couple more examples. But if I had, say, 10 to the power of 4 equals 10,000, let's try converting it into logarithmic form. So again, we write log first. We put our base in, so our base 10 of whatever the result is, and that's going to equal 4. So we're saying using the base 10, if we have 10,000, what will the power be? It's going to be 4. Let's do another example. I'll just block that off here. So let's look inside here. So let's say I had 6 to the power of x equals 216. Well, again, I write log to represent logarithm. I've got base 6 here, of 216 equals x. So that's converted from index form to logarithm form. Pretty straightforward process. Now we'll look at actually going one step further here and actually solving that a bit later on, but it's a pretty straightforward kind of process. Just look at going the other way really quick. If I had, say, log of 2, or log base 2, 8 equals 3. Again, here, this is going to be my power for my index. This number here will be whatever my base is, log of base 2, and then this here would be whatever x is going to be. So if I was to convert that, well, let's get my base. It's going to be 2. My power's on this side here. My power 3 is going to equal 8. And that makes sense. 2 to the power 3 is going to be 8. And the process of converting really doesn't get much harder than that. If we look at, for example, log of base 25, 5 equals 1/2. Well, again, we know our base is always down next to the log, so we're going to index form. So I'll have 25. Our power is going to be in the right-hand side, equals 5. And that makes sense. We know that 25 to the power of a half is going to be 5. Now, there's other questions that you could get that might look something like evaluate. So it might say evaluate log base 3, 81. So what it's pretty much trying to do is find the power or the exponent that you would need to use using base 3 to get 81. So our base is the important thing we're looking at here, using base 3. So we can do this two ways. We could rewrite this and convert this to a base 3 number with a power. So in this instance, it would be log base 3, well, 3, because it's our base, the power of 4. So therefore, if I was going to evaluate that, I would say that 4 would be my answer, because we have now found the power. Whatever we want to take base 32 to actually equal 81. Or the other way is, well, I could convert this here to index form. So let's have a look. Let's convert it to index form. I've got base 3 to the power of, well, we don't know yet. It's going to equal 81. And we could evaluate that now and say, well, x3, x is going to be to the power of 4 to equal 81. And we can get our answer that way. So it's a pretty straightforward process to go from one to the other, and also evaluating logs. Yeah, that's it.